So I think we are good to go, sir. And, before we start this particular, this special, industry expert session that we have organized today, whereby we request you to talk about, what are the vitals which are really, really important, from the perspective of making students, ready, from the perspective of Industry 4.0. I extend on behalf of ISBR family a big thanks to you, because people like you are stalwarts whenever we talk about the industry, and learning from you, it's like one blessing for us. So thank you so much for taking out time from your busy schedule, and agreeing upon for taking this particular session for ISBR students. And I am now handing over the session to Shashwat Shukla, who happens to be a global student of ours from ISBR. Shashwat, over to you.
Thank you, ma'am. Good afternoon, everyone present here. My name is Shashwat Shukla, and I welcome you all on this industry expert session about Industry 4.0 preparedness. This is going to be very informative and in-depth session about how to be industry fit. So before we start today's session, I'd like to introduce our speaker for today, Mr. Nitin Saini. He has completed his engineering from Delhi College of Engineering. He did his MBA in Business Analytics from Nasi Monjee Institute of Management Studies, Mumbai. After that, he pursued his doctorate from Swiss School of Business and Management. He has almost 20 years of work experience in Tata Consultancy Services, handling various projects efficiently and effectively. He is a competent strategist with 2 decades of proven track record delivering business transformation solutions, sales growth, and profitability through business and technical platform improvements. He has successfully delivered business systems integration and transformation project in America, Europe, and Asia. He is currently the mentor of change in Atal Innovation Mission AIM Niti Aayog. Now, without further ado, I'd like to request the industry expert to take over the session.
Thank you, Shashwat.
Good afternoon, sir. Over to you, sir.
Good afternoon. Good afternoon, everyone. Good afternoon, students and other folks who joined. Shashwat actually did part of my job. I had actually put up my slides to introduce myself. Thank you for the introduction, Shashwat. 2 things I would add into it, that I have worked in multiple domains ranging from life insurance to healthcare to retail to life sciences, travel, and currently working in the public services sector. And I worked in multiple geographies. I have keen interest in AI, traveling, and photography. So today's session, we are going to understand Industry 4.0. These are some of the terms that we are hearing on and off. But let's understand what exactly is history of Industry 4.0. What technologies are covered in the Industry 4.0? Why do we need Industry 4.0? And what's the future outlook? So in the history, let's first understand the industrial revolutions and its connection with the Industry 4.0. So let's start with a question. Do you know what this is? Anyone can unmute and can tell me, what is this? Do you recognize this thing?
It's a stone grinder.
Okay. Anyone else? What is it used for?
To powder grains.
Very true.
Sir, actually, Shomadip here, sir.
Yes.
So, sir, what is Industry 4.0? Basically, the technology has been developed in such a way that right now, all the digital service and everything, the use of AI, IoT, ML, this will be increased day by day. And also blockchain technology is coming in different field of business. So by mixing these technologies, the products and service are going to be something different. And also technology like 5G is coming. So in accordance to that, the whole technology will make the business run in a much sophisticated way, in a much cost-savely, it will save cost, I guess, and it will give us more productivity.
Absolutely, you are correct, Soumyadeep. In the coming slides, we are going to understand it better, what exactly encompasses Industry 4.0 and how it is actually helping deliver new products in an efficient way. So coming back, do you know what this is? Anyone? You can unmute and
Yes,
tell
sir.
me.
This is the turbine which is getting utilized for producing, I guess, electricity.
No,
Or they
anyone
are
else?
Sir, I don't know the name, but I know it's used for segregation purpose of the dust and some important some agricultural products.
Okay, anyone else?
Sir, it's to fetch water from the well or the river.
Okay, and you can do it by making the canals. Why do you have this wheel and the water flowing over it? Any guesses? All right, so this is a water wheel. This is used to move large stones for grinding the wheat. Just like you saw the hand grinding wheel previously, this one is more at the larger scale and it can grind wheat at a much faster pace. Now let's see, do you know what this is? Anyone?
the modern equipment for grinding of wheat.
Yes.
Like that is used in local places to grind the wheat.
Yeah, in the local term, it's called atta chakki. All right, let's see who knows this. What is this? Make some wild guesses.
So this
No
is the
guesses?
modern way of, converting what we get from the farm to, what we get to eat, in the form of a chapati.
Yes, this is a floor meal.
Right,
That is
sir.
correct. Now you saw 4 pictures right from the hand grinder to the floor mill. This gives you a glimpse of Industry 4.0. So Industry 4.0 actually evolved with each of the industrial revolutions. The first industrial revolution brought in the steam power and the water power. So the water wheel that you saw utilized the power of the water to move the stone to grind the wheat into the flour. Then you saw the electrical wheat grinder, which is called the atta chakki, that was utilizing the electrical energy to do some work. The last picture, which showed the floor mill was actually using some programmable logic control or the PLCs to generate the flour at the large scale, at the mass production. And what you have today is the cyber physical world where you are leveraging IT and other technologies to do something wonderful.
I am so sorry, sir, for the inconvenience caused. I request Vinod to kindly go on mute and Gautam Goyal also. Gautam and Vinod, kindly please be on mute.
All right. So if you look at the timeline, somewhere in the late 18th century, the industrial revolution came in with the water and the steam power. Then somewhere around the late 19th century, you saw the second industrial revolution where the electricity was being used. Somewhere in the mid 20 or the late 20th century, you saw the PLCs coming into picture where small robots came in. And today, the use of robotics is quite much. And if you see the work that was being done in the early days was much simpler, but it is becoming complex as we are moving ahead. So to summarize, the first industrial revolution was actually creating the goods using the machines instead of hand. The second revolution utilized the newer technologies, especially around the communication. And then the oil, gas, and electric power was leveraged. And the first assembly line was created at that time. In the third industrial revolution, the technology started coming into picture, the PLCs came into picture, the IT started getting integrated into the manufacturing processes. And now, today, the fourth industrial revolution, you are merging the physical systems and the cyber systems together to create the cyber physical systems, and the factories and the manufacturing processes are becoming smarter and smarter. Now, this Industry 4.0 has 4 key characteristics. The first one is the vertical networking. Second is the horizontal integration. The third one is through engineering across the value chain. And lastly is the acceleration using the exponential technologies. Now, when I say vertical networking, it means the integration between all the functions within the factory or the company that is producing the finished product. Horizontal integration is the integration across all the partners that create this value for the customers. And we'll see more in detail as we move ahead. And through engineering is leveraging engineering right from the first step to the last step of producing the end product, how you're utilizing the engineering to make the products efficient, better, of good quality, and with the lower costs. And with the exponential technologies, for example, the sensors, those technologies are becoming very, very affordable. And how do you tap in and how do you create the acceleration around your processes? Industry 4.0 has 6 design principles. The first one is interoperability. What does it mean is the ability of the cyber physical systems, for example, the assembly stations, the products, the workpiece carriers, humans, and the smart factories. How do they connect and communicate with each other using IoT and the Internet of Services? Second is virtualization. What does it mean? In other terms, it is also called the simulation. When you create a virtual copy of a factory by linking your sensor data and then monitoring it, you create your virtual plant models. You create the simulation of your plants, and then you try out or observe or monitor these systems very closely. Third is the decentralization. It is the ability of the smart factories to make the decisions on their own. This is the decentralization of the decision making. Then comes the real-time capability. With all these sensors coming in, a lot of data being generated, how do you utilize this data in the real time to make some insights and take the actions in the real time? Fifth one is the service orientation. What does it mean is it's the offering of these services, be it the cyber physical systems or the humans or the smart factories. You leverage the Internet of Services and deliver the services to each other and make the things happen. And lastly is the modularity. It's the flexible adaptation of the smart factories for ever-changing requirements in the individual modules. So now that you have understood the 4 characteristics, 6 design principles, let's look at the building blocks. Let's look at the building blocks. There are essentially 9 building blocks of Industry 4.0. Starts with additive manufacturing, augmented reality, autonomous robots, big data, cloud computing, cybersecurity, system integration, IoT, and simulation. Next, we are going to understand each of these technologies. What are these technologies? What do they offer? What are the benefits of using these technologies? But before we move ahead, any questions so far? Okay, so let's move to additive manufacturing.
Excuse me, sir. Sorry to interrupt.
Yes.
There is one question from one of our students, Vineet.
Yes, please tell me.
Sir, basically my question is, you are saying making smart factories and aligning it with different technologies. But how will we target tier 2 and tier 3 cities where there are more of family-owned small-scale businesses like retail and wholesale business? So how do we target them to align with Industry 4.0?
Well, Industry 4.0 historically has been focused on the manufacturing processes. Okay, so you typically talk about the small scale to large scale factories where the things are being made, and how do you leverage the technologies to make these manufacturing processes more streamlined, more efficient, reducing the cost, reducing the time to market, and all other things. What you are asking is mostly around the small retail shops, the mom and pop shops. They would have a play in this Industry 4.0. They are able to leverage this information that is available from Industry 4.0, because I'll give you an example. For example, the Zara fashion retailer, its parent company is Inditex. They have, automated their processes using Industry 4.0. The benefit of this automation is, where you used to get one product in 3 months, it is now reduced to 10 days. Right from the concept to the stores, it can be delivered in 10 days. So the smaller, let's say if you go to the tier 2 cities and you are running a fashion showroom and you want a particular, and you're finding a particular liking of a design, a lot of queries around that, maybe you can talk to the manufacturers and say, this is something what the customer is looking for. And because Industry 4.0 is enabling the manufacturers to create the products at a faster pace, your consumer demand can be fulfilled relatively faster as compared to today, where Industry 4.0 may not be leveraged by everyone. So that's how they can play a role in this Industry 4.0. Unless they are running their own, manufacturing processes, they can also leverage this. Okay, does that help, Vinay?
Yes, sir.
All right. Any other question? All right, so let's go to additive manufacturing. Does anyone know what is additive manufacturing? Has anyone heard this term? Make some wild guesses what this is. Anyone? All right, so as the picture shows, it is adding something and creating something. It is also known as 3D printing. Now, this is one of the key things in Industry 4.0, because 3D printing has been introduced somewhere in 1985. Some industries were leveraging it for certain purposes, but rest of the verticals did not realize the power of 3D printing. And now they have realized the power of 3D printing and they are tapping in very well. Earlier, this 3D printing was being used as a prototyping tool. You could prototype a new product before you put it into production. At that time, they used to use some resins to demonstrate, see this, how this product is going to look like. But now you can use a variety of products to print your things. Even in the medical science, they are using the human cells to print some of the organs. And we'll see more in the coming slides. This has actually reduced the transportation distances and the costs. And the industries are now leveraging it very well. So let's understand this additive manufacturing. As I told somewhere in 1987, the first additive manufacturing system came to picture, and it used the technology called the stereolithography. What it used to do is, it used to use resin, and they used to use the laser beam to solidify that resin layer, and the product was uprised, and the next layer was hardened, and the next layer was hardened. At this time, all the products were manufactured in the reverse way, which means you made something, you made the platform up, and it was all upside down. So if you have to print a swan, it will print the legs first, and then it will print the head. So that's how the things were being done, and it was mostly used for the prototyping purposes. That time, only resins were being used. But then the research was continuously going on, because it was limiting how 3D printing could be well leveraged across different verticals. And then they came up with the new resins that didn't require any of the laser lights, but you could use the normal light to solidify those resins. And then in early 1990s, that technology came in, that kind of resin came in, and they started using it. But then, although the use of the laser was reduced and the normal light was being used, but still it was less usable. For example, if automotive industry was to use this 3D printing for printing any of the parts, they were not able to do it because those resins were not very durable. Then the research continued, and they figured out new things, new technologies, how 3D printing could be used without melting or use of the metals and other kind of materials. So in early 21st century, they were able to find out new composites, new metals that can be used for 3D printing. If you understand the process of 3D printing, it essentially has 5 steps. It starts with, creating a CAD model or a 3D model. Then you create a STL file. This is the file, this is the format file which is used, which is understandable by any of the 3D printers. Then you create the sliced layers out of this STL file, because all of the 3D printers print by layer. So each layer has to be fed into the printer. So these slice layers are fed, and then the 3D printer is going to print the object for you using your choice of material. And it may not be a finally finished product. So the last part would be, and making it a finished product. For example, if you are printing using a metal and you need a very fine polishing, that has to be done manually. And then you get the final product. So as I told, this AM technologies, they started with the stereo lithography, and then new technologies came in. For example, multi-jet modeling came into there. Then electronic beam melting came into there. Then selective heat sintering, ultrasonic consolidation, and lastly, the laser metal deposition came in. Now, this laser metal deposition and the selective laser sintering is something which is heavily being used as of today, and it is being used to create the metal products. What they do is they spread the metal powder around it, and then they have the laser which melts that and fuse that into one layer, and the powder is removed, the next layer of powder is done, and then it again fuses this, and you can create beautiful finished products out of it. It may not be fully finished, but still the quality is very, very good. Now, the advantages of such additive manufacturing is, one, the design complexity is handled. You can design complex products in CAD, convert it into STL, make the slices, and the printer is able to print that. Now, the speed to market is there because you can print whenever it is needed. To give you an example, earlier in the aerospace sector, they used to ask for these spare parts, and it used to take around 3 months to procure that part. With the 3D printing, they are able to do it in 2 or 3 days because they can print it then and there. Then the waste reduction is there. As I told, when the metal powder is spread, the remaining powder is again collected, it's again used. So the waste that is generated out of the additive manufacturing is very much reduced. However, it cannot replace the traditional manufacturing for the reasons 3D printing is a slow process. So you cannot do mass productions around that. Then the choice of materials is very limited. You have certain resins, certain composites, certain metals, and now the human cell is also coming in. But again, that's very limited use. You do not have choice that I want this to be made in brass, this to be made in gold, this to be made in silver, etc. Maybe in the coming time, it may be able to handle all the materials, but as of today, it has a limited choice. And lastly, if you have to manufacture large parts, printing can take enormous a whole lot of time, which may make it, unsustainable. So for the time being, the additive manufacturing and traditional manufacturing both are there. Each has its own benefits around that. Let's look at how some of the industries are leveraging the additive manufacturing as of today, and what kind of possibilities are there in future. So if you look at the commercial airspace and the defense sector, they are creating some structural and non-structural parts for their own use. The attempt is to create the complex engine parts and the aircraft wings and all other things. In the space industry, if you look, some of the parts of the rocket, some of the part of the satellites, those are being created by 3D printing, and they are actually attempting to make the larger parts, or maybe take the 3D printing to the space, and you print the spare parts then and there to make the International Space Center by all itself, rather than taking these huge pieces there and assembling there. Then in the automotive sector, especially in the antique cars, you don't get those engine parts and all other parts today because nobody is manufacturing. 3D printing is a rescuer there. You can recreate those parts and use it. Their attempt is to, in future, they want to recreate all of the parts of the antique cars and the sports cars by itself using the 3D printing. In healthcare, as I said, they're using prosthetics and the implants. Those are 3D printed. And the attempt is to, create the organs by 3D printing of human cells. For example, if you can recreate the heart, or if you can recreate the lungs, or you can recreate any of the other organs that can be used for the transplantation. And lastly, retail has been experimenting around with the additive manufacturing for quite some time. They have been able to do something around the jewelry and the watches and all other things. What they want to do is they want to create the customized living spaces at some point of time where 3D printing would come into picture. You might have heard one of the Chinese companies actually attempted to 3D print a house. While it can be done, the finishing again needs the human labor. The kind of finesse that is needed to create the finished products is a little far-fetched in the 3D printing. Hopefully in the coming times, it will be achieved. Next technology is the augmented reality. Anyone who knows augmented reality? What is augmented reality? Make some wild guesses.
Yes, sir.
Hi, sir.
Augmented. Oh,
Okay.
sorry.
Go ahead.
Yes.
So augmented reality is, sir, basically the gamification we have seen in the Pokemon game or something like that, where we can involve the outside of our surrounding within our platform, like in tablet or in computer or in mobile. We can use this technology to include the surrounding within our gadget.
Yes. Anyone else would like to add here?
Yeah, it's actually when you are seeing any products online, you can visualize how that will look like in your place or in a particular wall or something like that. So it will give you a real feeling.
Yes, that's correct. As you all said, it is overlaying of the digital content on a real environment.
Mr. Nitin, can I request you kindly please give me co-host rights so that I can take care of this disturbance coming in? Shubham Kumar, can I request you to please go on mute? Shubham, thank you. So, sir, can I request you to kindly give me co-host rights so that I can take care?
Yes, absolutely.
Please, thank you.
And how do I do that? Okay. Okay, make co-host.
Yeah, you need to
All right.
click on my name. Yeah.
Yes, I have made you the co-host.
Thank you. Thank you so much, sir. Thank you.
All right. So coming back to augmented reality. So augmented reality is the overlaying of the digital content, the real environment. And as one of the students told, Pokemon game is one of the good example of the augmented reality, where you see the real world, but then you see some of the digital content, and that is coming as part of the game. But there are more uses of augmented reality. Let's explore in the coming slides. The AR system is actually, because it is having digital content, and you need to see this digital content on something. So you need to have some kind of a variable where you can visualize the things while you're looking at the real system as well. And the use of the augmented reality is currently being, leveraged in the maintenance service and the QA part, especially in the training part, where you have to give the technical training. The augmented reality is leveraged. When I talk about the augmented reality, many people come back with the question, what we see in the games is also augmented reality, is it not? And then I say, no, it's virtual reality, it is not augmented reality. So let's understand what's the difference between virtual reality and augmented reality. So virtual reality is you are creating the virtual world. When you're looking at that thing, it is completely virtual. Nothing exists. It's only what you are seeing. Whereas augmented reality is you're looking at the real world, but then something is superimposed on top of it to have some additional information. So as one of the participants told, you can actually visualize the things. For example, how does that sofa look like in my living room? While you're looking at the living room, the sofa is superimposed on that so that you're able to visualize how things are going to look like. Now, this augmented reality, there are multiple opportunity areas where you can use this. You can use it for connecting. You can connect people remotely. You can communicate and enable the individuals to view and interact with the same data or with the same viewpoint. And one of the persons said in the chat, it's the holographic thing. Yes, holopresence is one of the use case of the augmented reality. Then you can use it to know something more. You can augment the data and the resources, especially useful for professionals, engineers, designers to find new ways to do their work. Then you can use it to learn things. You can immerse in training, you can immerse in analytics, research. You can lower the time, risk, and cost required around that. Then you can use it to explore. You can bring the consumers on a journey of exploration across time and geography. And the tourism sector is actually leveraging this. They are giving the virtual tours of the monuments using the augmented reality. Then you can use it to play. You can have the digital reality experiences through content creation, content enablement, consumption of that content, and all those things. Then you can use it to think. How? You can evaluate the solutions, you can devise best practices, you can build business cases, and you can determine a long-term vision. So the opportunities to use augmented reality is huge. Now, if you look at some of the industry and some of the different ways how they are leveraging augmented reality, for example, if you look at retail, it is actually using the augmented shopping. It is using it in the live events. They are using it for behavioral analytics. It is they are using for in-store experiences. They are creating the augmented catalogs. They are using it for the immersive training, and they are using it to enhance their physical products. If you look at the pharma, they're using it for gamification. They're using it for maintenance. They're using it for safety and compliance. They're using it for visualization, and they're also using it for the immersive training. If you look at the education sector, they're using it for gamification. They're using for the immersive training, and lastly, they're using for the storytelling. So each of the industry is tapping into augmented reality in some way or the other. Hopefully, in the coming time, they are able to make the best use of the augmented reality for multiple uses. Next comes the autonomous robots. Can anyone tell what is an autonomous robot? What do you understand by this term? Anyone?
Sir, I think it is related to artificial intelligence.
Okay. What else? What else do you know about autonomous robots? Or what do you think this autonomous robots is? Less human intervention, yes. What else? Robotic process automation. Automatically, robots work without human control. Yes, all of you are pointing towards the right thing. Now, autonomous robots, they are programmed to perform certain tasks with least human interventions. You can assign them a task and then they will do that task very diligently without anyone needing to supervise it. But then you want these robots to be more versatile. They should be able to do more than one work. They should be able to take the decisions by themselves, and wherever they need, they can reach out to humans and say, I'm not able to make the decision, and humans are able to help them. Now let's understand these terms. As you know, a robot is a device that performs a function that a typical human would do. The earliest robot or the example of a robot is a calculator. It's a simple calculation. You could do it using the calculators. Now, when we attach the word autonomous, it means robot can work independently once it has been programmed, and no human intervention should be required when they are doing their jobs. Now in this, a new term has come into the talking, and it is called cobots. Now cobot is a robot that has been designed to work with humans to help or augment the work that the humans would be doing. Now these are the things where some kind of a risk is involved, or it may not be ergonomically suitable for the humans. You would assign those work to the robots. For example, welding, painting, assembling, packaging, inspection, testing, all those things. And the reason for doing so is because they have high endurance, they have high speed and high precision. Humans have the capability, they can work for 8 hours at a stretch and then they would get tired, may not be able to continue beyond that. However, robots can continue to work for several hours in one stretch. They have high speed and they have high precision as well. Now let's look at this chart, which is made between task complexity and the environment. When the environment is fixed and the task is so simple that no logic is required, you can use traditional robotics. When the environment becomes a little flexible and it requires some logic, you have to bring the advanced robotics to handle such kind of things. When the environment is totally unstructured and there is a need to develop the logic, no robot can do that work and humans have to do that kind of a work. Hopefully, in the coming time, the robots will be intelligent enough by the use of AI and all other things that they are able to develop the logic by themselves and they can work in the unstructured environments as well. To give you an example, now using AI, the books can be written. And there was a demonstration a few weeks back where the AI has actually written a book. You tell, and it will give you the perspective, and it will give you the unbiased perspective on that topic. We humans tend to have our own biases, and it's reflected in any of the creative work that we are doing. However, when AI is generating that, it is unbiased. You can even generate the paintings now. You can give a rough figure, and it will create a painting around that. So the robotics and AI is going to achieve that uh, milestone where they are able to generate the logic by themselves. However, working in the unstructured environment, that's still in progress. Hopefully, someday we'll achieve that. Now, what are the benefits of autonomous robots? They're smart. There's a supermarket called Ocado in UK that is actually using these humanoid robots for tricky maintenance jobs. They're easy to use. You might have heard Foxconn, who makes this Apple, Samsung, and Microsoft devices. They have reduced their human workers and they have replaced with the robots because it requires a high precision work and they are easy to use. Then easier ergonomics. So as I told, um, in some of the ergonomically disadvantaged positions where humans may not be able to work, you can position these robots. And in one of the German industrial company, what they have done, they have put these cobots and they have this soft skin. Whenever it touches the human being, they understand they have to stop and it immediately stops, ensures that the humans are not hurt. Then you can use the autonomous robots for the improved productivity. And I was giving this example, Inditex, who is the parent company of Zara, they have automated their processes to the extent that they can move their product from the design stage to the floors in just 10 days. Then you can use the autonomous robots for the precision accuracy. When you are printing the chips, when you are printing the motherboards, you need to use these robots because they have very high precision. And one of the use cases is in the automotive sector, um, you have to put the shock absorbers and it needs a very pinpoint accuracy and it needs very dexterity and the strength around that. These robots play a wonderful role there. And lastly, if you can leverage these cobots along with the humans, you can use the collaboration generated out of it for the best advantage of the consumer. Now let's come to big data and analytics. This is the term which has been there out in the market for several years. Can anyone guess and tell what does big data mean? Anyone make some wild guesses? Data with large volume, huge pile of data. Yes, what else?
Sir, actually, big data is the we are using digital products for so many days, and in upcoming days also the market is expanding. So the huge amount of data regarding customers, and so that big data pile of data can be analyzed properly, and the decision can be taken in accordance to that. And also by utilizing those, we can utilize these IoT devices also to like analyze those data in screening, and also in running the machines and everything for production, more
Right,
production and less cost.
right. Somebody in the chat wrote random data generated by IoT. Yes, all of this is big data. And you have to realize where this big data is actually coming. Because you have these sensors available, they are transmitting the data continuously. You have internet around, you are able to talk with other humans, you are able to interact with other devices. Each one of them is transmitting some kind of a data back to you. All of this data collectively is called the big data. Now, every data may not be a useful data, so you have to run analytics to make some best use of this data. And you have to figure out what data is useful for me and what can I derive from it. And you leverage artificial intelligence around that to figure out how the data can be leveraged and how it can be used to predict some of my future. How can I generate the insights into the future regarding my product, regarding my manufacturing process, regarding how my organization is to move ahead, and other things. So a typical analytics process is you collect the data, you cleanse the data, you process the data, and then you analyze this data. Now I was delivering one more lecture on big data, and somebody said these 4 steps are somewhat similar to what we do in BI, the business intelligence. We also collect the data, we also cleanse the data, we also process the data, and we also analyze the data. So how is this BI different from big data? So I put this slide, a business intelligence versus the advanced analytics or the big data. Now in business intelligence, what you do is you are doing the post facto analysis. What happened? When did it happen? Who did it? How many were affected? All those kind of questions are answered. And what you generate out of it is you generate some kind of a report, which is reporting against KPIs, metrics, or you might be creating some dashboards or these scorecards, or you might be creating some kind of cubes that you can slice and dice. So all those things are post facto thing. Now when we talk about the big data analytics or the advanced analytics, it talks about why did it happen, will it happen again, and what will happen if we change certain parameters, what else does it tell that we never thought to ask. And what it gives in return is it gives you some statistical or quantitative analysis. It gives the predictive modeling. You can do the multivariate testing around that. You can do the text analytics. You can predict something in future. And the next phase to it is the prescriptive analytics. How do you leverage this data to first understand what happened, what can happen in future, and what is that I need to do? That is the prescriptive analysis. It tells you what should be your next step. Now, the benefit of such kind of analytics is you can acquire your customer and you can retain the customer as well. Simple example is Amazon, Netflix, and Spotify, because they understand their customers very closely. Every time you are doing a transaction with Amazon, it is learning more about you. Then you can have the targeted ads. And Amazon is one of the good examples where they are using this very well, because they understand you very well. If you have searched, let's say, for a basketball on Amazon, and next time you go to Google, you will start seeing the ads around basketball. They use this cookies data to give you a target targeted ad so that you are prompted to take some action around those things. Then you can use this big data analytics around your product development. Now that you understand your customer well and what they need, you can develop your product in such a way that it meets their need very well. You can use it for price optimization, and some of the large retailers like Walmart, Target, they use this very heavily when they are into the market. What price to be brought up and what price to be brought down so that the customer is happy and I'm not losing money around that. For example, they might reduce the price on the eggs and they might increase the price on the milk. They might be losing the margins on some side, but they are able to cover up those margins on the other side. So how do you optimize such tactics? Then you can use it for supply chain and channel analytics, where you need to have the real-time information. In the pandemic period, Pfizer was one of the vaccine which was positioned to be used in India. However, it was not allowed the entry because it used some cold chain around that, especially in the logistics, because it had to be kept at a very low temperatures. But if you look at the cold chains in America, they were shipping these Pfizers. They had to keep the real-time information, whether the temperature is dropping or increasing, whether it is reaching on time or not. So this big data and analytics will give you the information, and you're able to make some insight out of it and take some actions accordingly. You can also use big data and analytics for your risk management. Now, when you are doing the analysis around the data, you will be able to find certain patterns and you're able to make some actions around this. Walmart, they were collecting this data for a huge time about their customers and the shopping patterns. One thing what they observed was around the Thanksgiving, people used to shop a lot. And just after the Thanksgiving, people used to return the items a lot. And the returns were mostly without the receipt. And they were worried because their policy said they can customer can return the products without the receipt as well. When they did the analysis, they figured out the items, the kind of items that were being purchased in bulk and returned in bulk before the Thanksgiving and after the Thanksgiving was around the barbecue stuff and the tents and all other things. And this was also observed around the holiday season as well. And what they figured out from the pattern is people tend to buy this stuff just before their vacations. They used to use this stuff for 7 days or 10 days, whatever be their vacation duration, and they would return these items back. So they don't have to invest into those items, and they're able to get good returns. So Walmart, after they figured out this pattern, they were able to reduce their risk by now implementing the blacklisting of customers who are returning the items without the receipt 3 times. Now in US, if you go and return the item to Walmart without a receipt, they will accept it. However, they are noting this person X has returned 1 times, person X returned 2 times, person X has returned 3 times. The 4th time you will go, you are a blacklisted customer, and then your return will not be accepted. So you can make beautiful insights from such data. And lastly, you can improve your decision making. And this is one good example that I just now articulated on Walmart, how you can make the decisions. Nobody can go and randomly make the decision, okay, let's start blacklisting the people without the receipts and they are returning the products. No, it has to be backed by the data. So you are able to make the good decisions around that. Next is cloud computing. What do you think cloud computing is? Make some wild guesses. What could be this cloud computing? Mind you, it has nothing to do with the rains. Anyone? All right, so let's go to cloud computing. Now, cloud computing is you have to run your processes on some kind of a server, which would need some computation power and some storage. Historically, all of the organizations used to have their own servers, own storage and compute residing somewhere, typically called the data centers. However, the upkeep of the data centers is a huge task. With the cloud coming in and the internet coming in, you can host your application on somebody else's compute and somebody else's storage. And when you do this, you are able to reduce your capex expenses and you are able to convert it into the opex expenses. And you don't have the overhead of maintaining such data centers. Now, when people realized this thing, that I don't have to invest into something and I don't have to worry about the maintenance of the data center, etc., they quickly adopted cloud. Now, interesting thing is this cloud is reducing the cost for you when you adopt the cloud. And the reason is, for example, if I am the cloud provider, I would have thousands of servers with me. And you would be needing, let's say, 50 servers or 60 servers. I would give you 50, 60 servers. But when I am putting up this huge data center, because of the economy of the scale, I am able to procure it and set it up at a lower cost. And I am able to give it to you at a lower cost as well. So if you look at the cloud computing, Amazon Cloud or AWS is the leader in this cloud market. And the cloud market is estimated to be $180 billion big. The next two players are the Azure and Google Cloud, each having their own specialities. With multiple clouds coming into picture, even the multi-cloud is being talked about. However, some industries are slow in adopting it. Some industries are quick to adopt the clouds. And your cloud can be a private cloud or it can be a public cloud. When I say private, it means it's solely for you. And when I say public, it is still again for you, but it's on a common server, common data center. So it will be used by other people as well. And how you can leverage cloud? You can leverage it in three ways. You can ask for infrastructure as a service, or platform as a service, or software as a service. Infrastructure as a service, or it is also known as IaaS, in which you just get the infrastructure and then you have to plan the OS and the applications around that. So you are responsible for most of the things except the hardware. Hardware is maintained by the CSP or the cloud service provider. In platform as a service, or commonly known as PaaS, you are given the hardware with the OS and the middleware and the runtime. You have to worry only about the application and the data. And lastly, software as a service, or SaaS, in which everything is managed by the cloud service provider. A very good example is the Gmail service that you use. It is a very good example of software as a service. You just have to go draft your email and then forget. You don't worry about who has written this application, how it is working, where is my data going, what kind of server is needed behind that. You are just consuming the service and it's all there. Now, what are the benefits of the cloud? As I said, less costs. It is 24/7 available. It is flexible in capacity. So which means today you are consuming 100 GB of data and tomorrow you need another 50 GB of data. You don't have to worry about procuring it. It automatically gives you that additional capacity because somebody at the cloud service provider is monitoring it, and most of it is now automated. Accessibility is there because it is cloud and accessible through internet. So you can access it from any part of the world, be it India, be it US, be it Europe, be it UK. The automatic updates on the software are automatically done. You don't have to worry about that. Security mechanisms are there. Data is encrypted while at motion or at rest. And you can have additional security controls placed around that. And we'll learn more about in the coming slides. You can reduce the carbon footprint. Now, these data centers, they typically generate a lot of heat. So you have to cool these data centers. A lot of cooling goes into these data centers. Now with the cloud, everything at one place. So the cooling requirements have reduced, and all of the cloud providers are now focusing on the green cloud, how they can reduce the carbon footprint on the world by way of these data centers. Some have even tried having the data center kept into the sea so that it doesn't need that kind of cooling. Some have attempted to put that into Alaska and Arctic, to reduce the cooling thing. A lot of things are being done. Then with the cloud, you have the enhanced collaboration because same thing is accessible from any part of the world. You have control on documents. You have the authentication built in. You can ensure who is able to view those documents, who are able to edit those documents, and it is easy to manage. Now, the chart on the right side of the slide that shows the adoption of the cloud. The digital native companies, they are the front runners in this race. They have the highest adoption, followed by media, gaming, and the retail. Some of the laggards in this race are the public sector, manufacturing, banking, those kind of industries. But sooner or later, everything is going to go on the cloud. That is what is predicted. Then comes cyber security. Oh wait, it's 3:31. Do you want to take a 5 minutes break, or it's okay to continue, Shashwat?
So I think it's continue to.
So we can continue, and I think if you need a break, we can always
Yes, sir.
have
No,
a
no,
breather,
that's okay.
just a breather in between. Yeah,
I just
because I
wanted to
can
make sure
understand
the
when
odd.
it's late, it is difficult, to speak,
No, that's
continuously.
okay. I have a glass of water with me and taking sips in between. No, I just wanted to make sure the audience is comfortable enough.
No, I must say, sir, the examples that you're quoting so far, and the kind of discussions, or rather, the points that you're putting forward, especially the Walmart one that you have put forward so far, and the one where you gave us a good differentiation between business intelligence, and at the same time advanced analytics.
Advanced.
No doubt it was really insightful. And it's not just the students, those who are here learning, but rather you are enriching all of us.
Thank
And
you.
it is
It's
an
a
honor
pleasure
to
to
have
be.
you, sir, I must say.
Thank you.
Yes, sir.
All right, so let's continue and
Please,
let's
please.
go to cyber security. Make some wild guesses. What is cyber security? You might have heard this. What do you think cyber security is? Anyone? Securing data over internet. Very good. What else? Anyone would like to unmute and tell what is cyber security?
Safety from phishing, scams, etc., securing a network, a bandwidth, and yeah. Securing data and making sure data doesn't go into the wrong hands.
Absolutely. You are very much correct. Now, let's understand why do we need cyber security? Now, because of the internet, a lot of data is flowing, be it from the sensors, be it from other factories, other players, other partners. The data is continuously flowing. So you have to protect this data because all kind of data is being fed into your system to make some useful insights out of it. And you want to implement the zero trust architecture, and we'll talk about the zero trust architecture in the coming slides. But you want to make sure one who is intended to use this data is able to access this data. It shouldn't be the data is lying there and somebody is coming and having a look into it, peek into it and doing this. So protecting the data is very, very important as the technology is advancing. So as one of the participants told, phishing and all kind of other attacks, those are the things that needs to be protected. Now, phishing and the social engineering based attacks, these are the common things where somebody is attempting to extract the data out of you. and they would assume and they would pose as if they are the legitimate people, and they will trick you into giving the data. That is called a phishing attack. Then there are attacks around the internet facing services. When you expose your APIs and services to the outer world, somebody may be able to tap into that and extract the information because they have the access to those APIs and the services. You have to protect that. Then password related compromises. This is very common. You might be hearing in the news that, you know, somebody hacked into the data and so many passwords are exposed. Because now the tendency is when you log in into Google Chrome and into a new site, it automatically saves the user ID and the password. And if you are keeping very common passwords and people are able to access such information, they'll be able to tap into that. And they'll be able to extract the information which they are not, for which they are not the intended recipients. Then misuse of information. Unauthorized users can have the access to some confidential information, and they can, you know, use it for various reasons. Then the other kind of cyber attack is the man in the middle attack. Like we are talking, if this connection is not secure enough and somebody eavesdrop into this line and tries to tap in, it's a kind of an attack. Thanks to the encryption, the data in motion is encrypted. So even if somebody taps into it, will not be able to make any sense out of it. Then the supply chain attacks are there, where, you know, destroy the logistics communication, or you break that inventory level information and all other things. Then comes the denial of service attacks. This is the common attack that you might have heard and have seen. Sometimes you might have seen this website is down. Mostly it is because of the denial of service. And the new mode of denial of service, or the DOS attack, is the DDoS, distributed denial of service. And interestingly, few days back, Google reported the largest DDoS attack that was ever attempted in the human mankind. Interesting statistics are 46 million user attempts in 1 second. That was the scale of the DDoS attack that was attempted few days back on the Google Cloud for one of the customer. And it lasted for 10 to 11 minutes and it was safe. The security mechanism around the Google Cloud was so strong, it didn't let the website go down. They were able to handle it. But just imagine the scale, 46 million requests per second. And lastly is the ransomware. You might have heard this. Somebody put a malicious code into the system by various means, and it acts as a goon, and it will ask for a ransom. Unless you give me so many dollars, your laptop will not be decrypted. It will encrypt all the files. Your laptop or the system would be encrypted, and you will not be able to use it for anything. So all kind of cyber attacks are there, and new ways of cyber attacks are coming in. That's why this cyber security is the ever hot topic as of today. Now, given all these things, what can you do around this? You can have network and perimeter security built around. You can have the endpoint security built around. You can have your application security. You can have the data security. You can have identity and access management, and you can have the zero trust architecture. Now, if you are implementing all these securities separately, which is a need, you can do that. But then security is now being built in all the practices. So security by default is something which is now being implemented by all the IT players here. So you don't have to, worry about that there are vulnerabilities in my application, or if I left the vulnerability at the server level or at the network router level, because you are making this as a practice. It's by default. You secure all the systems, but consciously also you have to ensure the things are taken care well. Now coming to the zero trust architecture that I spoke about, now there is a implicit trust, I mean, that was the trust that was established, which said, this user is in my security perimeter, I don't need to worry. But that thought process is now changing, and it is getting replaced by an adaptive and an explicit trust. What does it mean is, unless the user is authenticated with multi-factor authentication, with the corporate laptop, with a functioning security suite, I am not going to accept this as a legitimate user. So you don't put the trust on anyone unless they prove that there is that they are the legitimate users. So that's the zero trust architecture, where all the players are slowly adopting the zero trust architecture, and it is the need of the hour. Now let's go to the system integration, or the horizontal vertical integration that we spoke about, the four characteristics of Industry 4.0. One of the characteristics was the horizontal and the vertical integration. Any wild guesses around what these integrations are? What do you understand by horizontal integration and vertical integration? Anyone? Make some wild guesses. You don't have to be right. No guesses? All right. So now one of the key elements of the backbone of Industry 4.0 is the horizontal and the vertical integration. What does that mean is, horizontal integration is the integration across the multiple production facilities and across the entire supply chain. Whereas vertical integration is the integration within your organization or within your factory. And you are ensuring the data right from the first process to the last process where the end product is being created. The data is flowing uninterrupted. Everyone has the access to data where they need to access it. So horizontal integration is basically the networking between the manufacturing sites. Customer involvement is there in this process, and you are continuously exchanging the information across the value chain. And you have the system communication, the intelligent system communication in the demand, logistics, and the production. Whereas this vertical integration is the integration across all the functions in your organization or the company or the factory, right from the product planning to the production processes. And you leverage the IT systems to communicate at all levels, be it operating and monitoring, be it the system control, be it the machine control, be it the sensors, actuators, anyone. Let's understand this a little more in detail. Let's say you have a factory in America and you are producing some finished products. Right from the product ideation to the product creation, if you are able to flow this data uninterruptedly across all the systems, then you have achieved the vertical integration. When you are able to have this data communicated to another facility, let's say in Australia as well, and you are able to receive this information back to this manufacturing site as and when needed, involving customer and other players in the value chain as well, you have achieved the horizontal integration. And you ensure it by having end-to-end engineering at all levels, be it this company or this factory to this company to this factory, or all other players involved into it. Then comes the Internet of Things. Make some wild guesses. What is Internet of Things? Anyone? This is something very common you might have heard, Internet of Things. Make some guesses. Connecting to internet or network. Okay. What else?
So basically, making the products to think on their own, bringing AI into the products itself so that they can think on their own and advance. For example, robotics is an example of Internet of Things.
Okay. What else? Make some more guesses. What does the word internet? Yeah, sorry, go ahead.
Anything related to sensors.
Okay, very good. What do you think internet in the Internet of Things mean? Why it is called Internet of Things? Okay, so Internet of Things is called Internet of Things because it is the Internet of Things. What does it mean is all things are talking to everyone by the way of internet. Now, Internet of Things was previously called Industrial Internet of Things, and it is not a new term that has come in. It was always there. Whenever different things are talking to each other, giving or receiving the data through the use of internet, it is called the Internet of Things. Why it is becoming so hot these days? Because there are devices that are continuously emanating the data, and there are devices who are continuously consuming this data by the way of internet, and that's where the Internet of Things are coming into picture. Be it robots, be it machinery, be it products, they use the sensor data, use the RFID data, they use all kind of other data, and they send it in the real time, and they consume it in the real time to know something about what needs to be done next. Maybe it's about the condition, it may be about the performance, or it may be about the location, and all those things. So in a typical business process, what would you do? You would perform your activities like you're manufacturing a good, you're marketing a product, or you're managing the people, you're handling the finances, etc. In doing so, you have employed some sensors. Now, these sensors are continuously monitoring and emanating the data. For example, in your manufacturing plant, there are sensors who are measuring the temperature. Some sensors are looking at the acoustics. Some sensors are looking at the vibration data and all. Now, with all this data coming in, you have to perform the data analysis. You have to collect this data and do the analysis. Now, you can do the analysis either in the cloud, or you can do the data analysis at the edge, which brings us to the edge computing. And we'll talk about the edge computing in the coming slides. Now with this data, you can do the big data analytics, you can do the descriptive analysis, you can do the predictive analysis, and you can also do the cognitive analysis around that. Now by doing this analysis, it has to lead to some insights. What is that you have figured out from this? So these insights can reduce your production delays. These insights can lead to maintenance capacity increase, or it might give you a trigger. Oh, you might be missing your shipping deadline, and likewise. Each of these insights will lead to some action. For example, if there are production delays which are expected, you can order the parts now or automatically. Or if the maintenance capacity needs to be increased, you can notify the technician for the inspection now. Or if you know you are going to miss that shipping deadline, you inform the customer proactively, hey, there's some issue, and you can expect this thing to be arriving by a day late or 2 days late. So you have taken some actions which will impact your business activities, which will impact how the sensors and what kind of data it is producing, and likewise. So it's a cyclical process. You continuously utilize this data to make some meaningful insights and take some appropriate actions. So we talked about the edge computing. Now let's understand this edge computing in this way. Tesla is making those autonomous cars, and it is connected to the cloud. Enormous amount of data from those sensors is being fed into the cloud for some meaningful use. However, if some obstruction is in front of the autonomous vehicle, the vehicle has to take the action immediately. It cannot wait. Let my data go to the cloud, somebody do the analysis and give me the instructions. Okay, I should slow down. No, it cannot happen. It's needed real time, and it has to be really fast. It cannot be dependent on the cloud. So you need to have that computing power at the edge devices. What it means is that computing has to be there in the autonomous vehicle itself. You cannot afford to send this information to the cloud and receive it back. There are so many variables involved. You may not have the right bandwidth. You may not get the right response when you need it. And by that time, the damage might have occurred. So this is the edge computing architecture, what is typically used. You have these sensors which are emanating the data, and you have the edge computing servers around that are continuously consuming the data, ingesting the data, making some insights and giving you the instructions what to do next, and parallelly sending this information to the cloud for the later use. So as I told about the autonomous vehicles, they need to make the decision then and there because it is going to cost something. Then the healthcare devices. For example, if you have the variable that that tracks the fall of the patient, and if you happen to be unconscious and you fall down, the device cannot wait to send this information to the cloud and receive the input. Rather, it has to make a call to the doctor saying, hey, your patient has fallen down, or the BP has shot up to 200 beats per minute, and likewise. Similarly, on the security side, when there is a breach happening, you cannot afford to wait for the instructions. Rather, you have to take the decisions then and there, and maybe in few seconds or milliseconds. For example, I gave you the example of the DDoS attack that happened, 46 million requests coming in per second. Cloud has to take the decision. Those you cannot afford to make wait for the analysis to happen and then take the action. The action has to be taken immediately. Then retail advertising. If you are into a mall and you were searching for, let's say, the eyeglasses, and you are walking in front of the lens card, because it is consuming the data coming from your searches and all other actions. If they are not able to give you the targeted promotion at that time saying, hey, there's 50% off, why don't you come and buy the eyeglasses, they lose this opportunity. And that's where the big data analytics or the prescriptive analytics come into picture. It will tell you what is the next best option for the retailers. Then the smart speakers. The smart speakers, they have to listen and they have to do the action immediately. So if you were to talking to Alexa and saying, Alexa, switch on the light, you cannot afford that this data is going to the cloud and somebody is giving the instructions back, okay, switch on the light. You may not be connected to the internet at that time, but you're still talking to the Alexa. So Alexa has to take the decision then and there. Then video conferencing. The data is going to the cloud and coming to you. And if there is an issue at my end, if there are bandwidth issues, my system has to take an action what to do. For example, if you're onto the Zoom calls or MS Teams calls or WebEx calls, and you're facing the network bandwidth issue, it might switch off the video because it takes a lot of bandwidth. So those actions are needed then and there, and hence the use of the edge computing. Then comes the simulation or the digital twin. Make some guesses and tell me, what is digital twin? What do you think digital twin is? Or a simulation is? You can also unmute and tell, what do you think digital twin is? Anyone?
So students are requested to make this, session as interactive as they can. Specifically after listening to the way, Mr. Saini is delivering this lecture, I'm sure that, he is worth receiving, at least your responses. So I request each one of you to please unmute yourself if you feel like answering. And you can come on camera also.
See, one thing is, whether you know the things or not, you should make the wild guesses. That is how you learn. Digital replica, somebody said in chat, okay.
Parag.
What else?
Sir, it's a digital representation or the exact copy of a thing that is physically present in the real world.
Very nice. So that is correct. As the word says, it is the simulation or it is the digital twin. It is the virtual simulation of the real machine or a product or a process or a factory or a system, which is recreated based upon the IoT sensor data. And why do you need this? So that you are able to analyze the functions or the product or the factory for performance, for maintenance, and all other things. And this is very common in the industrial systems. You can create a digital twin and you can see how my process is going to fail if I change this thing. So if you have to bring a change into your process without actually letting your factory go down or shut down because something failed somewhere, you can actually play around with the digital twin. So let's understand this digital twin in this way. There are 5 key components or the enablers in the digital twin. The sensors and the actuators, they are sending the data, and they are able to send this data because you are integrating all those things together. Using the data which is sent through the integration, you run the analytics and you continuously update your digital twin. This is what new I have learned about the digital this process, and this needs to be updated so that whenever you are tweaking any of the processes, you are able to see the effect in the digital twin rather than the actual processes. So you are simulating before you are putting this into the practice. So there are physical processes. For example, you have this assembly line and there's a robot. So continuously the sensors are sending this information through the communication interfaces, and your digital twin is consuming this data and replicating the same process. In the physical process, there are multiple systems involved. For example, ERP is there, sensor is there, actuator is there, CAD system is there, which is actually making this process run. The edge computing hardware and the software and the security, it is passing some information into the digital twin where you have the data ingestion processes, you have the data lake, you consume this data, and then you have some AI processes and the cognitive engines running around that is rendering this digital twin and showing the behavior of the physical system in a virtual way. And you have dashboards coming out of it. You can visualize this thing and you can get the notifications around that. So essentially you are using these 6 steps. You're first creating the physical process, sensors are communicating, and you are accumulating this data, you are analyzing it, making an insight out of it, and then taking an action. The information is coming from the real world, but you are simulating in the virtual world and trying to see what actions I should be taking so that my processes are well handled. Now, the kind of business value that is delivered by digital twin is, before I go there, let me tell you one of the wonderful use cases of digital twin. Now, in the defense systems, when you are creating these large warships, you cannot create a warship and put it on the trial and see how it is going to behave. So you have to create a digital twin out of it. And you have to see what kind of load it is going to carry, what all weapons I am going to put onto it. If I am putting a missile around it, what thrust it is going to put onto it, whether it will go down or will it still float. How many planes it can land on top of it. How many helicopters can be there. If I'm putting a lot of energy generation mechanism, for example, if I'm using the nuclear fission or fusion technology to generate the electricity, and I have to measure the temperature during the wartime, the ship is going to get heated, the missile is going to get fired, it's going to emanate a lot of heat. The energy generation itself is going to generate a heat. And if the heat wave is also going around, what will be the effect? And if I'm firing 100 missiles in 1 minute, is it going to melt my ship or not? Now, in order to do that, you cannot afford to make a ship and try all those things. So you create the digital twin. You then attempt all these things to see whether my ship is stable enough, is it safe enough or not. Coming back to business values, so simulation and digital twin, it is going to help improve the quality. It can help you bring the warranty costs and the warranty services down because you are continuously monitoring your equipment to figure out whether it is in a usable condition or not. You're able to reduce your operation cost because by improving the design and the engineering around your machinery, you're able to see whether it is performing well or not, or if it has to improve the performance, what actions have to be taken. You can improve your record retention and the record serialization because you will be putting your own machinery, and then you are putting a lot of sensors. Which machinery part was procured when does the warranty ends, etc. All those things, if you are keeping it in the paper form, it's a huge task. But if you are keeping it digitally and using it well, you're able to make a very good use out of it. Then you can reduce your new product introduction cost and the lead time. You can also generate new revenue growth opportunities for yourself. Now we have understood 4 characteristics of Industry 4.0, 6 design considerations of Industry 4.0, and the 9 technologies around Industry 4.0. Before we step into why do we need Industry 4.0, if you have any of the questions, any of the thoughts, please do share before I move to the next step. Anyone?
Yeah. Hello, sir.
Yes.
Kamadip here. So I'm asking that how this technology industry for in case of service industry where people's involvement is really needed in case of customer service and stuff. So how this technology can be utilized there to give a better service maybe or to under like can this technology tell me that whether like at what time this problem will come? Can we predict also with this kind of data?
Yes, you can also predict this thing, and I'll give you an example. In railways, there are these wheels, and there are these, I'm forgetting the word. There are these bars that connect to the electricity wires in the electric engines. Um, Pantograph. These pantograph, when they touch to the wires, every time it touches, there is a spark, and lot of carbon is deposited there, and there is a wear and tear onto the pantographs as well. The wheels, when they are running onto the rails, they also get wear and tear. And if you look at the shape of the wheels, they have this small lip coming out that goes along with the rail so that it does not derail. It gets weared down when it is going on the rail. And if you look at the of the pantograph is going on, and they're continuously monitoring it. It tells them when to replace the pantograph before it stops, passing on the electricity and the train stop, or when the wheels are wheel lips are weared down to the extent that it can cause some kind of accident. It gives the trigger and it tells it has to be done now. And usually all of the moving parts have a warranty of, let's say, the wheel can go for 30,000 kilometers before it needs to be replaced. By having these sensors and the condition monitored, it can send you the trigger. So and so train, so and so engine, so and so wagon, so and so wheel needs to be replaced now. So at the end of the journey, they can go to the yard and get it fixed, or the wheels can be replaced. So it can predict when it is going to fail.
Yeah, so it can be utilized in bikes and cars also, I guess, to understand where at what time the tires need to get changed or the engine oil needs to get changed. Okay. Another thing is about digital products like another apps when multiple requests are coming inside like to use in different feature. And sometimes we see that those digital products get slowed down or those get completely disconnected. So can that also be identified through this technology, whether the system is going to run slow or whether the system is going to get closed for certain moments?
Mhm. So one is the predicted traffic during the festive season. For example, the Dashera is coming or Diwali is coming. People tend to do a lot of shopping at that time. So it is expected. So you know during that season the peak is going to touch. There could be peaks due to some attacks, or it may be that you have positioned the product so well that it is attracting a lot of traffic. For example,
Lots
Mahindra,
of
when
traffic, yeah.
yeah, so for example, Mahindra, when they launched their latest model, they got 100,000 booking in just 30 minutes, right? So huge traffic coming in, which is not a very usual thing for any of the automotive manufacturer. So you can predict, especially by looking at the past, that typically during the August to September time frame, you tend to get a lot of traffic because a lot of shopping is going to happen. So you need to be well prepared, right? Or if it is a unplanned traffic coming in, and if you are on cloud, you are still in the safe hands. If your system is architected well, it will automatically scale horizontally. That's where people are now moving to cloud, because it gives you the scalability option without bringing your system down. On prem, if you have not made the scalability options built into your architecture, your system is most likely going to go down with a lot of traffic. But if you have the scalable mechanism done, it can be 100,000 requests, it can be 200,000 requests, still your system is able to handle it. And then there are concepts of what is that called? Load balancing. If you have implemented the load balancing, you can direct your traffic. Let's say you're getting a lot of traffics in India, and you're getting very low traffic, let's say in Nepal. You can divert your traffic to Nepal if you have the load balancing done manually or automatically. That can be done. So you can safeguard your IT systems accordingly. As far as prediction is concerned, looking at the past data using the big data analysis, predictive analysis, something can be other
Thank you.
thoughts?
Thank you for the
Sure. Any other thoughts before we move ahead?
Hello, sir. Nilesh here.
Yes, yes, Nilesh.
My question is about the product industry because is
Mhm.
how it will create impact, because in fintech now we have adapted the lot of industry the technology, but in many areas of products we cannot adapt that fast in India. So what your prediction about this product industry in this about industry 4.0?
See, Industry 4.0 historically, if you see, has been more liking in the manufacturing sector, because all these technologies that we are seeing are mostly used in the manufacturing. However, other industries have started utilizing the remaining technologies. Out of these nine, for example, additive manufacturing, if you look at other industries, retail or something, they may not be using this additive manufacturing as of today, but they are leveraging the big data analytics, they are leveraging AR, they are leveraging cloud computing and all other things. So sooner or later, Industry 4.0 is going to be utilized by everyone in some shape or form. In IT sector, Industry 4.0 has its twin called Business 4.0. So the IT companies are using Business 4.0, which is mostly around SMAC, social, mobile computing, artificial intelligence, and then cloud. These are the four things that people are using in all the industries. People didn't realize the social has tremendous uh, role Today, if you're not getting a Uber service, you put a tweet onto Twitter and then you get a response, right? If you're not getting the right service from any of the airline services, you put a tweet on Twitter and then you get a response. Traditionally, you would write an email or you would call them and nobody takes care of it. But with social, a lot of focus has come in. So all these things have its own benefits. So Business 4.0 is going to be leveraged in all the industries, and remaining part which are not yet in Business 4.0 will also be consumed in some shape or form sooner or later. Does that
Yes,
help,
yes,
Nilesh?
definitely. Yes, sir. This next generation will definitely go through this all the changes. Next 10 to 20 years,
Yes,
1 to 2 years will definitely impact.
absolutely.
Yes, thank you so much.
Sure. Any other thoughts before we move ahead?
Shashwat, do we have more questions pouring in? Shashwat, if you can hear me.
Yes, ma'am. Am I audible?
Yes, you are.
Okay, so now we don't have any questions for now. We can move ahead.
All right.
Thank you.
So now that you have
Yes.
understood Industry 4.0, let's see, why do we need Industry 4.0? So the digital technologies or the exponential technologies that we are talking about in Industry 4.0, they are causing the increased automation. They are enabling the predictive maintenance. They are enabling the optimization of processes, and they are bringing the new level of efficiencies. What does this mean is you're able to create the intelligent products through intelligent factories, leveraging the intelligent assets, and then the empowered people. So when I say intelligent products, it means you are developing connected, self-aware products that are capable of sharing the information about their health, location, usage level, storage conditions, and many more. Especially in the logistics area, this is very, very important. When I say intelligent factories, you are running the factories which are highly digitized, they are autonomous, they're taking the full advantage of these exponential technologies like big data, robotics, artificial intelligence, IoT, and they are also called Factory 4.0. Some of the players, they call these intelligent factories as Factory 4.0, and they are self-correcting. They are employing the smart manufacturing processes. They're able to deliver the customized products in a very cost-effective way, and that too at a scale. When I say intelligent assets, every physical asset today usually has a built-in sensor, which can be connected to IoT and analytics, and it acts as the game changer for the enterprise asset management, especially around the maintenance and monitoring it. If you're able to prevent the downtimes, you're able to produce better. Then comes the empowered people. Empowered people means you can be autonomous. You can make your systems as autonomous as possible, but you will still need people. Not everything can be done by the robots and the machines, but you can empower those people by the technologies like AI, the sensor data, so that they are able to make the decisions that machines cannot make the decisions. Wearables, augmented reality apps, all those things are enabling it. Let's look at some of the benefits of Industry 4.0. One, you get an enhanced productivity through optimization and automation. Then you're able to develop the innovative capabilities. You are able to find new revenue models around this because you are agile enough, because you are able to personalize and customize for the new consumer, because you have better working conditions and sustainability. You are able to build better quality products because you have real-time monitoring, or you have IoT, or you have cobots, or you have quality improvements done. And because you have this predictive maintenance built in, because of Industry 4.0, your business continuity is much advanced than any other. And you're able to track all of this information in the real time, in the real supply chain to create the real-time economy. Now, let's look at some of the statistics around that. Now, when I say improving quality, what does that mean? This one example is from a Fortune 500 assembly company, which had this assembly line built in, and they were able to get their product first time right by 10 percentage points. So that's the beauty of the quality improvement in Industry 4.0. It can streamline the processes. There is one manufacturer, one electronic manufacturer, which leveraged the cobots, which doubled their labeling speed from 125 parts per hour to 250 parts per hour. And they were able to reduce the floor space by 200 square feet. Then you can reduce the development cost and the lead time. So one of the truck engine manufacturer, it leveraged the 3D printing to their benefit, and they reduced their tooling time from 20 weeks to 2 weeks, and they decreased their costs from $10,000 to $770. You can accelerate your market entry. One of the industrial goods company, they reduced their quality claims by 90%, and they increased the production by 25%. Because they implemented the Industry 4.0 and they were able to predict the things much faster than others. You can create new services. As one of the participants was saying, can we predict in the case of bikes and cars and then etc. This is one good example. One of the tire manufacturers based out of India, they have actually put the sensors around their tires to figure out how it is impacting, how it is, what is the tire pressure, what is the speed, consumption, location, and how these are correlated. What is the best combination to have the most durable tire being created? And they have also created a digital twin using the sensor data to figure out what are the new kind of tires I can produce, which will be much durable and much lasting. So this Tires by Mile initiative is generating a new revenue for this company. Then you can have significant change in the efficiency in your factory's efficiency. So one of the automotive equipment supplier, they were thinking how to improve their digital strategy and take different initiatives. So they identified small initiatives, and they called it as the lighthouse projects, and they were able to rapidly test these initiatives and then showcase the value of digital by the way of use of the exponential technologies. Then you can optimize your operations. In one of the gold mines in Africa, they identified the problem that the oxygen levels were fluctuating too much during the leaching process. And this was all possible because of the sensors. By looking at the sensor data, they were able to analyze and fix that problem. And they were able to increase their yield by 3.7%, which means they were able to save around $20 million annually. And lastly, you can have, improved productivity by the way of use of AR and all other things in maintenance, training, etc. Besides this, I'll tell you one of the cosmetics retailer or a manufacturer, I would say, they have to try their cosmetics on animals by the way of the clinical trials before it is tried onto humans. Now it has, if you look at the data, 93% of the clinical trials lead to the failures, which means only 7% of the clinical trials will be successful on animals, and then it will be tried on to humans, and then once it is marked as safe, it will be made available for the human use. And because it is the cruelty to animals, because of the clinical trials, this cosmetic manufacturer, what they did is they created the digital skin out of it. Now, digital skin had all the parameters how a normal skin would react to various chemicals and different reagents. By creating this, they were able to test the new cosmetic products onto the digital skin before it is tried onto the animals. And it removed 80 to 90% of the failures. This is one example how digital twin is helping the manufacturing sector. Another example is the vaccines. Now the pharma companies, again, they have to do the clinical trial of the vaccines on the animals, then onto the human beings. Only then it is made available to the public. You might have also heard one of the vaccine manufacturer in US recently revealed that 44% of the women who received the COVID vaccination led to abortions. Such thing happens when the accelerated clinical trials happen, bypassing some of the usual processes. But again, when you don't have time and scale and you don't want to be cruel enough, digital twin can come to your rescue. You can create the digital twin of a human body and then monitor how the vaccine is going to create a reaction onto the body, whether it will lead to any adverse reaction or not, and then you bring it safely to the public. And there are numerous examples where the Industry 4.0 is getting leveraged. Now that you have heard about Industry 4.0, what does it comprise? What was the history? What's the benefit? What does the outlook look like? So look at this chart. This chart is prepared by World Economic Forum, and it is part of the Future of Jobs survey that was conducted in 2020. And the intention of this chart was to figure out what technologies are likely to be adopted by 2025. The top technologies are the cloud computing, big data analytics, IoT, cybersecurity, artificial intelligence, image processing, robots, augmented reality, etc. What is noticeable here is the cybersecurity part. If you look at what was the level in 2018 versus what will be or what is expected in 2025, it's a remarkable increase, because now the IoT and all other things are coming into picture. You need to make your systems more secure. Then the next one is cloud computing. As companies and the industry are realizing the benefits and the power of cloud computing, they are adopting very well. And likewise, other technologies. Have a look at these new materials, the nanotubes, graphene, etc. Combine it with 3D printing and just imagine the kind of things you can achieve by using graphene and 3D printing. You will be able to maybe create the buildings out of 3D printing using graphene and all those things, and it will be resistant to earthquakes and all other things. You will be able to create the International Space Station out of graphene, which is very lightweight and very strong. And if you're able to club it with 3D printing, you can make wonders out of it. And then quantum computing, while it is in the nascent stages, has the tremendous potential. The amount of processing power will go up by 1,000 times if quantum computing comes in the general life. Now let's look at the technologies, how these will be adopted by 2025 and by sectors. So I'll bring to your attention these things where you can see more greens than reds. Big data analytics has a tremendous role in digital ICT technologies, in education sector, in transportation sector, in manufacturing sector, in the financial services. Same is the cloud computing, tremendous impact onto ICT companies, onto the education sector, onto the financial services, government sector, manufacturing sector, transportation sector. Likewise, cybersecurity, Internet of Things, artificial intelligence. All of these things are gaining traction across the industries. So today you are doing your post-graduation, tomorrow you will be into the real world, and you will be part of one of these sectors, and you can see what kind of changes and the transformation these technologies can bring in. And then lastly is the text, image, and voice processing, which is slowly picking up, and it is going to have a tremendous impact in all these industries in the coming times. So that's all I had for this session. If you have any questions, any thoughts, observations, please do share.
Thank you, sir. We'll go ahead and take some time for questions now. I request all the students to post their queries in the chat box, or you can unmute yourself and ask the question to sir.
So before we take up the questions, sir, I must say that, you know, the session was very, very insightful. And at the same time, sir, that the students are so moved that, you know, I have got more than, 50 messages, on my phone, where the students are asking for the presentation that you have shown today. Because they say that, to keep having, this information with them, and even to, develop deeper insights later on, they would really like to, refer to the kind of knowledge that you have delivered.
Absolutely.
So big thanks to you, sir. Big thanks.
Sure.
Okay, sir.
Yes,
so
sir.
looks like we have a few questions. This question is from one of our student, Jennifer. Her question is, data compiled in the process of manufacturing or any other stage is a crucial data, which not all the companies are willing to share. So how can companies work in this disruption?
So there is a concept called data marketplace that is coming up. And if you look at the hype cycle, the Gartner publishes this hype cycle every year onto the technologies, especially on the emerging technologies. The latest one is going to get released next week. But if you look at the last year's hype cycle, it talks about not the last year, last year, it talks about the data marketplace. That is the concept which is coming in, and it is picking up the pace in the all the sectors. And what it says is, I have enormous data from my company. How can I make it available for others use, or maybe used by the startups, so that we can collaboratively or co-create some new products out of it? Because this data is very, very valuable. It's only in this century that we have realized data is the new oil. They haven't realized data is the new gold. Actually, it is so precious that you can do wonders using this data. And it is only the tip of the iceberg that we have seen how big data can actually leverage this data to give you the insights for better functioning of your organization or the company or the factory, but also it can help the rest of the players in this ecosystem. Now the focus from the company, the focus is shifting from the company or to the consumer to the ecosystem now. Now people are building the ecosystems. They are talking about the value chain end to end. And I'll give you an example. Airports. Airports have typically been seen as a place where you will wait, kind of a waiting house, and then you will board the flight and go away. Now the airports are thinking in a new way. How can I make this as a recreational place where people come and enjoy and they don't get stressed out? In California, what they have done is, during the peak hours, they have created a recreation park very near to the airport. During the peak times, they send the alert to the passengers that it's the peak time, your flight is still 30 minutes away or 1 hour away. Why don't you go to the recreation place and get yourself stress-free? And by creating these recreation places, they have invited the retailers, new startups to come and showcase the things that are valuable for these long journey haulers. So they are creating this ecosystem. Then the need for the parking is there. So the parking players come into picture. because now everyone is having the vehicles and they prefer to have their own vehicles. So parking spaces there. Retail shops have come into pictures. Then the spas have come into there. New clubs are coming in there. Eateries have cropped up. So now people are not looking at only their business, but they are looking at the ecosystem. How can I develop this ecosystem? How can I make the data available? And thanks to the open technologies, they are making this data available through the use of the open architecture and the open APIs, which means the data is accessible through APIs. And another example is Ayushman Bharat, the big initiative in India where it is giving the coverage to crores of people who may not be able to afford a good healthcare. As part of this, they are coming up with the digital health cards, and they are leveraging this data that will be captured, and not the PI data, not the personally identifiable data, but the data around the healthcare, efficiency of the healthcare, to be exposed to the startups by the way of APIs, so that new products can be built. For example, health wallets is something which is being talked about. And what these health wallets are, when you get a treatment, you tend to go to different doctors, they get the different prescriptions, different diagnosis. These health wallets would be the entire history or the lineage of your line of treatment, so that in future, if you are getting a treatment, the doctor is able to see, okay, you got the treatment for X in the last 5 years, and my line of treatment has to be in agreement with that treatment, and likewise. So the opportunities are there. The data is currently not being shared for their own good reasons. Sooner or later, all the players will realize exchange of the data through the use of the data marketplace or APIs would enable their businesses to grow. Hope that helps Jennifer's question.
Yes, sir. Yes, sir. Sure.
Indeed, sir.
So,
Indeed.
The next question is from one of our students, Vineet. His question is, Atal Community Innovation Center, which is led forefront by Niti Aayog, is an illustrious campaign idea, but this idea has only been limited to 14 states as of now. How is Niti Aayog planning to spread awareness of this campaign to other states as well?
Okay, you'll have to repeat that question. Sorry, I was a little distracted.
Okay, so his question is, Atal Community Innovation Center, which is led forefront by Niti Aayog, is an illustrious campaign idea, but this idea has only been limited to 9 states as of now. So how is Niti Aayog planning to spread awareness of this campaign to other states as well?
Okay, so the mentor of change, the regional mentor of change, the regional teacher of change, and the student mentors, this community that has been created by Atal Innovation Mission is enabling the spreading of information across all other states. So any of the big initiatives is usually piloted in few states, spread across few more states, and then it is spread across the entire geographic region. So how mentor of change are helping? Now, if you look at, and I come from Delhi, so I'll talk about Delhi. In Delhi itself, there are a lot of schools who do not know about the Atal Innovation Mission and how they can create these incubation centers, how they can create the Atal Tinkering Labs in their schools itself. So it is our responsibility as mentor of change, and then regional mentor of change. We go and talk to the schools and tell them how government is planning to do certain things by way of Atal Innovation Mission. What is that they get in return? What is that their students get in return? So these are some ways how we are spreading this information. Then the other way is conducting the hackathons and other things. For example, the Smart India Hackathon, which is currently going on. When you hear about such things, you go and talk to your school and your college administration and figure out how we can participate into this. That triggers the idea into that. So those are some of the ways how the things are spreading across the states. Does that help?
Yes, sir, indeed.
Sure.
Sir, it looks like we have covered all our questions. You answered most of the questions during the sessions also. Sir, is there anything you would like to add or cover for our PGDM students? Any advice you would like to give?
Yes, I'm having a look at the time. It is 4:35 and we are 5 minutes beyond our scheduled time. Is it okay to continue, Supriya ji?
Sir, I'm so sorry. You know, we have already taken too much of your time, keeping in mind that you are a busy person working for an organization which is already making, you know, big tides, you know, when it comes to our economy, India. So I think, Shashwat, we can stop here. Thank you so much, sir, again, once more time, you know, for taking out, you know, your valuable time here and, you know, spending, sharing, you know, your quality insights with us. Thank you so much.
Thank you.
Thank you one more
Now,
time. Thank you again.
Before we close, one parting remark that I would want to make to all the students.
Yes.
All of you who are present in this session and who are doing the post-graduation, you all are very blessed people because you are doing your education in the age of abundance. Remember this thing. If you look at 10, 20, 30 years back, we didn't had so much information readily available to everyone. We didn't had internet. But today you are so much well connected with the information every time. And India is on a path in the Amrit Kal, as what the minister says. In the next 25 years, we have to take India to the level where India is seen as the true Vishwa Guru. And it is responsibility of all of you, where now that you are stepping into the industries with the knowledge that you are gaining, do the wonders and make India a true Vishwa Guru in the next coming years. Use this technology, knowledge that you are gaining today to create something wonderful. Don't limit yourself to only jobs. Try to create the jobs. That is one thing I would say. You have done post-graduation. You have become the masters in certain subject. Leverage it to the best extent. Create new jobs. That's what I would say. Thank you all. And thank you, Supriya ji, for this opportunity. Thanks, Shashwat, for organizing this.
Thank you. Big thanks to you, sir. Big thanks to you. You know,
Thank you
very
so much.
rare people like you we have got in the industry, those who are there, you know, to share their knowledge and at the same time making sure that, you know, the knowledge that they are gaining is, you know, is taking India to the right direction. Thank you. Thank you once again.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you so much.
Thank you all. Bye-bye.
Great having you, sir.
Thank you.
It's great. Thank you, sir.